Welcome back, guys. So today, I guess last week we were trying to get the syscall working to test our block layer so that we can have multiple user processes trying to read or write to some block, and based on our syncing mechanism using spinlock, our entire block layer should work without any syncing errors, that is any race conditions. We tried that and we were left with some, what is it, table faults, page faults, because that particular syscall is not within the memory, so that is what is causing it. And last week I mentioned that maybe we could write a helper that can act like the exec syscall. So what exec syscall does is, in general, it takes out a block of memory or blob of whatever exe or whatever file system specific thing, and put it into memory, load specific shared libraries, load the things that it needs into its virtual memory, so that the process on its own can do something about it. Hi, yeah. So yes, that's what we were trying to do, and we want to achieve, so that we don't have to manually update our user process every time, because currently my init task sets up the stack and stuff, and we also where is it? Yeah, we map the entry function, which is the user actual bytes that needs to be executed into the virtual space. So, and the actual bytes lies within the kernel code. So we also have to update the tables. But in a real world scenario, the actual bytes will just be a blob of data, and it will be inside probably a file system. So we open the file, take it, we load it into memory, and pull out all the libraries that it needs, which in our case it needs this syswrite to be in, so it can use it. It also needs urprintf, because this is also not inside the memory. That's why I had to remove it and then try it, and I got the fault here. So this is the high level of what we have to achieve this week. But overall, we are still trying to finish up our block layer for our own kernel, and so far things are working, like scheduler and memory management unit. And what else is working? And also the kernel separation is working. Those parts are fine. Now we are working on the block layer, and we want to get that going. Okay, let's see. And okay, so we need, currently we have sysmap not mapped into user table, and I don't want to take the shortcut of just mapping the syscall into the user process like we do here. That would be the easiest solution. We can, like the way we do it here, we can just map it and it should work. But I don't want to do that. Yeah, I want to make it flexible, so that my C hard. Why? C is the easiest language. C++ is hard. C is easy. C++, try C++. It will fuck you up. There's just so much metadata going on. It's just, I don't know, I don't like, I mean, like C++ has really good use cases. Like when I read the V8 code base, I mean, I really like C++, but then I don't think I would love working with it, because it's just gonna fuck with us every day and we'll eventually get tired of it. C is just plain and easy to use. I think C is the best language out there, and it's not hard. You just have to get used to it. It's not C++ is hard. Okay, and syswrite. Okay, let's see what we can do. We want exec, and it should be flexible enough to load anything into the memory. And every time, currently my init task is like exec, because I start two processes here. What the fuck is that? Yeah, I start two processes, and in general it is doing something like that because it is taking the process, it is also setting up stack. Maybe I can consider this as my exec, but I don't know, should I consider it or not? Okay. But overall this is what we want to achieve. So we simply want to take the file from the file system and use it, but we are still trying to, I mean, we have already finished up the file system. Now we can actually store the bytes into the memory and read it. So I think we can do that. We can do this, but we don't have a file here yet. We can only read a block, and it will return a char buffer. Maybe we don't want to complicate that now. That will be for future. Now let's just add. We want to add what? What do we want to add? Helper that can map any library into the task. That's all I need, right? I need currently I have the stack, I have the actual instructions that are already mapped, and I have the tables. Now I need the actual libraries. Okay, I also need the vtable. Without vtable, even if I map the new libraries into a user process, how will the user process actually know where a particular function is? Because from this point of view, from kernel point of view, I can simply call syswrite, because the linker is converting this into some reference and it is directly hard coded into the kernel ELF. So inside a user processes, even if I link this syswrite, the user processes on its own will not know what syswrite is. So I need that vtable to convert the process, no, that's just the address, into some. So I need technically a linker for the user space. But we want to keep it simple. Let's write something hard coded then. Where is it? We want a helper that can map the library into task, and we want to make sure all the references are linked as in, if example, if we use syswrite, and if we load it into virtual space, let's say 0x8 something, if this is where the syswrite is linked, but the instructions, as you can see here, this is where we stopped last time, and as you can see, syswrite is linked to this address 8001F38, and the instruction would have something like 0x01F38. So now we need some sort of way or linking to convert this into this address, or we just link all the addresses into, because this is a physical address within, at least a virtual address within kernel space, and this is an address within virtual space. Maybe we can add a table entry from here to here. So we add page table entry for within user space VA from this mapped into this. That should also work. This should work, but is it enough? I mean, it should work, but I'm not sure if it's enough for future cases. But in reality, in user space, there should be a compiler. The compiler should know that this syswrite is something that is linked into a library, and it should know that it has to take that address and map it to this. So it's the compiler's job, maybe. So as of now, we don't have to worry about it, and let's just write a simple page table entry mapping, so that internally the instruction is going to be mapped to whatever it is to the external VA. Yeah, so we don't have to move around things, we just map it. And what do we do? Yep. And it's actually easy. Kernel to user space. We do have a helper, but what does it do? Where's my fucking thing? Okay, here's it. Map user space to kernel. Okay, what does it do? It takes an ID and an address. And we have two user space tables. And I don't like this implementation. Identity map the user space into kernel space region. So what we are saying is that If kernel space has 0x, I mean, like in kernel space, syswrite is within this 0x111f30. No, this is user space. In user space, this function address is at this location, and if I simply identity map this 1f into the physical range of 132, would I have the same value? Maybe we can test this out. It's not hard. It's pretty simple. We just stop at this location, we run it, and we are inside start. You can go past that. Now we are inside user process. So user process table is currently loaded. So we can't do that. We need to quit it. First of all, inside kernel space. Let's just add the breakpoints. This breakpoint is added to this particular function. It's added into this function. So this is where we enter into user context, and so we add a breakpoint there. And now let's disassemble syswrite. So syswrite inside kernel sits here. Let's take that example, take our example, so it's pretty easy to manage. Where the fuck is that? Okay, let's take okay, yeah, so the actual syswrite is within this address 0x1f38, and currently we have the which kernel page tables. So probably this is actually mapped into physical space, which is, I don't know what it is, but probably it is mapped into some physical range, because this is a virtual address. Or is it not? Wait, let's move into break gaming. Let's get to here. I think if we run it here, we are inside the k-main, and at this point the actual kernel's virtual tables are loaded. So now if we try to disassemble syswrite, it is still in this, but we should be able to reach it with 0xFFF. Yes, we are able to reach it. So this is the kernel address, and it is mapped directly, identity mapped into probably this range, because everything inside my kernel is identity mapped. Let's double check it. Yeah, it is that. Let's put 32, and it's SVC, and here we have SVC. So this is identity, this is the virtual address. Embedded systems. I don't know. Well, how do you structure it? Wanted to learn and should do systems. I think you can just start with without using standard lib. Try a simple freestanding executable that prints something into your uh, screen. So you would directly be using the memory mapped address to reach your display and write a hello world, compile it, run it. Then you'd get a small idea of what embedded systems is, because most probably you wouldn't have a fully fledged operating system there. And even if you have an operating system in embedded systems, most probably they are real time, so you don't get to have lots of things that a general purpose kernel has. So yeah, mostly think about it in terms of C without standard library and try things out. That only example that comes into my mind is that a simple example of maybe reading from any sensors that you have. If you have a laptop, probably you have a keyboard and mouse. You can read sensors from it directly. You can probably it's mapped to some GPU port or something. Try to read from it without any libraries. Start that way. You'll get an idea of how C plays into embedded systems, but I'm not really sure because I haven't tried much of embedded systems. Only back in university I have worked with some small PCBs. Nothing much, I guess. But yeah, in general, to start with embedded systems, you just have to make sure you know how to interact with bare metal things overall. Other than that, do we need anything? I guess you also can't be really easy with pointers, because I think most of the embedded systems have some sort of subset of C where they have specific regulations of what needs to be in the code and what shouldn't be. I have one of my friend, he's working in what's it, Stellantis, I guess, in Maserati. He works with Maserati, but he's part of a company called Stellantis. And he said, he told me like they don't really write any code even before AI. Like they just use MATLAB to generate modules, and the modules will be converted into C code, and though that C code is just subset of the bigger C that we know, and it does not have like loops and stuff, I think, because everything should be bounded and it has to go through certain security standards and stuff. I'm not sure how. I've never read that code, but he's mostly working with the car, and I think that's also like embedded systems. And they work with like how brakes work, how engine should be turned off and stuff. Yeah, but and why did I even say that? Because I said I wanted to make a point, I forgot the point, but yeah, whatever. Where was I? So we have the FFF. This is our kernel virtual address. It is mapped to the actual physical address. Now what do we want is once we jump into the user process, we have a separate table, and in that table we don't have an entry for this. So what we want to do is that add a table entry into the user process, that maps from, I guess, maps from whatever location into this physical address. And because if we run it, oh, I didn't add the break. Not this. Okay. Let's rerun it. This instruction will get into user process. Currently we are still in the kernel and it's kernel tables, and when we put erets, now we'll load the user level table. Okay, so now we are within user process and we have a different table, and this table does not have an entry for this because we are just going to get into memory error. Maybe we can try this too. And we still don't have access to it, but GDB knows that this physical address actually has the syswrites, but our user table does not have that entry. So I think we just have to put in the user space, we just fill this with the same thing. So from user space 8x1f into kernel space physical address, and this is user virtual address. This is the easiest solution, but this should not be the actual solution. The actual solution should be something like we should have a table, and that table should have an entry like key should be, let's say, syswrite, and in user space, let's say the address is pointing to 801, and in physical space it is pointing to 0x812311f38, and our table should map from 0x80001 into 0x8001f38. This is how it should be, but we'll just do the identity mapping. So whatever is the PA, that will be the VA2. Oh, someday it's gonna bite me, which is fine. Until that day it will work. So how do we do that? We must have some Kernel-to-user space. Map user physical, and it's gonna do identity mapping. So maybe we just call, let's copy this and let's come back to our helper. Where did we write this entire thing? Oh, it's here. Let's paste it here. Okay, it also has this comment. Okay, ID is just that we have two processes, so that is hard coded. Currently I can only have two processes, and currently based on the ID it will be mapped. If it's ID1, it will be mapped into table 1. If it's ID2, it will be mapped into table 2. So that also needs to be changed, but that time will come. Here we just put syswrites. I think that is all. It should work. If it works for the entry, it should work for this too. Let's try. Now let's stop at this, run it. What the fuck? Where are we? What did I stop into? Fuck it. Okay, I did stop into the user first entry, that jump function. So we just no, something happened. I fucked up. I'm in some loop. Wait, let's circle back. What do we want to stop? We want to stop into disassemble first user enter. This is where I want to stop. Let's copy it. Maybe the things moved around because I added a new entry. I don't know. It's possible. Why the fuck is it not getting copied? Shit. Okay, this is the first one. Will it jump there? Maybe I'll just put FF. I don't know. At least either one of it should break. Now we'll run. Okay, we broke it here. Okay, now let's go past that entire thing. And we have the next instruction, that is ERIT. Now we are going to jump into the user process. Okay, we are inside the user process. Now let's try to see if we have access to this. We do. Oh, fuck. Okay, so that's solved. Now if we run it, what are we expecting? What should happen? We just call syswrite and nothing. Okay. And what does syswrite do? Okay, let's see. Okay, we have the syswrite instruction now. We jump into it. Okay, actually what happened is that interrupt has occurred, but I don't know why it happened the moment I entered into syswrite. Shouldn't it happen after I invoke this instruction? Yeah, something is happening. Maybe there was timer interrupt. I don't know, but only right now we are inside syswrite. And the moment we enter into syswrite, we are going back into this, and probably this is some error handler. Something is happening. Okay, let's kill it and let's just run it. Yeah, we're stuck. We are stuck. Do we need anything here? It's simple move instruction and stuff. Wait, let's try one more thing. If we go into our build, currently we have virtual IO trace. Let's remove that and let's turn on all logs, and we can remove camo. We'll remove all logs there and just run bash. And if I run it, okay, now we're stuck. Now if we come back into log cat, what am I supposed to grep for? I'm supposed to get for camel 1, and we grep for what? We grep for for, I forgot the explanation of it, but yeah, for. If we don't have any for errors, or we do have for errors, so let's see, put 5. Okay, and the error is we, as you can see, the exception started from EL0, so we were inside EL1, EL0, that is user process, and we went into EL1 for an exception of this instruction. We tried to use that instruction and it did not like it. And what is this instruction? That's gonna be the answer to this entire problem. And I need to get it from user process, but let's double check what it is here first of all. It is right. And why am I getting error? But we did add the entry. Okay, we'll stop here, we run it. What the fuck happens? Okay, maybe because we have logs, the entire address range got skewed. Whatever. Remove this, add this, run it. Fuck it. I have to add break. We add this break, run it. Okay, we are inside that. Actually, we are inside some. No, we are inside that. And we have the error. We jump into user process. Now here let's test it out. E32 plus 32 is working. Oh, just syswrite is not working. It's into some free pages. Now I get it. We are overlapping something. And syswrite starts at this location. Let's take this and put it here. And it is readable, then why is maybe it's not executable? Let's test this error code. Maybe it's possible. It's definitely possible. ELR error codes. And I only have to have this, not this. About let's try just this. decode that for, I think it's the write permissions. Oh no, execute permissions. That's missing. Something like that. Oh. We try to do something from an unaligned state. Is that what happens? But how? I think everything is 4 bytes aligned. No, everything is 16 bytes aligned, something like that. Oh, it's a fucking alignment issue. Can we confirm it? Because I don't want to fucking rely on this. And what's the error code? It is this x20 with 10000. And how do we find it here? We have it here. Maybe let's just copy and search for it. Looks like that. And what other information do we have? We have address. But why? I don't fucking understand. Instruction about from a lower exception level used for MMU files generated by instruction access and la 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 la. I thought so. It's a non-executable page. And yes, because my page is actually not executable. Probably. I don't know. Let's double check it. Where the fuck is my u? Oh, it's here. Okay, here we do the actual physical mapping and we add a lot of things and we don't do anything about setting pages executable. I think we set it as. Then how come I can run something? But how the fuck does entry function work first of all? Because that has to be also be executable. If that is working, this should also work. Because entry is also like, it's a similar state because here we have, what do we have here? we have entry. Oh, okay. Oh, what I do is that I convert the kernel into user space first of all. And what does that do? It simply zeros the upper bits, which is fine in our case because it's already zeroed. Or is it not? And if it wasn't, then we would have gotten some fault here. So probably this is not the issue. Okay, what happens after that? Fucking KMA. And then I don't do anything else. I just call map user entry with ID. That is it. That is it. I take a user entry. Let's check that then. See, that address is not there, so we definitely have the user syswrite is in this location, and this location is already mapped into the user space, but the only issue currently is that it's not executable, and it's not possible to execute anything there. But how come the user process is able to do the same thing? Because I have this entry function which is also here. Where is it? Where the fuck is my entry? Yeah, entry is just user process, which is this, and it is inside the kernel context. And what about syswrites? Syswrite should also be in the kernel context. But the moment I execute it, it's getting fucked up. No, it works. Oh, because the user process works. The syswrite is not working. This is the section, and then we jump into syswrite. Okay. So maybe I did not. I am able to see it here. Even plus 32 is working. So now if I put si, we are inside syswrite, and the first instruction just jumps into the exception handler. Okay, what can we do? We can copy this into our user process, but that would be lame. Why can't I map this just right into that? What's wrong with that? It says that I need to have specific executable permissions, But then this user process does not have it. This user process function, that is also mapped the same way. This is also mapped the same way, and it is working. Then how come I have no fucking clue. We have a syscall and we have a user process. Both are exactly the same, but syswrite is in a different location. Maybe that's the only difference I see. Okay. Syswrite is put into a different block of ELF. And user process is actually in 8000 C range. And syswrite is after free pages. And probably maybe it's a linker issue. Because if we go into our linker, we have a linker script that defines different sections of our kernel ELF. I don't know where the fuck is that now. It should be here. It's here. I think this is read-only data. The actual thing is supposed to be inside this. Because text is where I guess the instructions are put into. We can do one thing. It's pretty simple. We change this to 1 and copy this into kmain and see if it works. Because for some reason if we link it, it's getting put into some other location where we don't have any permission to write. Even now it's the same fucking error. Okay, let's see again. Disassemble syswrite. And we take this and break here. Okay, we are inside syswrite. And now it's in a different location, probably before user processes. And we don't have any upper bytes. Now if we put si, okay, it did work. Now it is working. We It's working, and this is where we actually move the value inside, and then we call the instruction which is going to start the interrupt. Now if we say, okay, we are supposed to go into the handler, and we are inside some handler when it must be our vector, and I think el on sync entry, probably we are here, and if we move things, we are currently checking if the interrupt is actually a syscall or not. If it is a syscall, we should have 0x1f in the exception register. And it is not taken because it is a syscall, and we go into syscall dispatcher, and syscall dispatcher just returns return. Why? If we go into syscall, no, we'll jump into it, and it just has return. Okay, I have it here. Shit. Let's just remove this. Okay, and we do have the number as current syscall as 0. So our syscall did work, but we still have some questions unanswered, but it's fine. Wait, let's double check it. We are inside handlers.c, and we have the syscall number, and we should also get this, and syscall number is 0. Then we do have something wrong. Get the syscall number should be 0x8 is the syscall. Syscall number instruction. I think it's x8. Yeah, it is x8. So it is correct. We are expecting 8th instruction, 8th argument to be the one that is holding the instruction syscall number. But I also want to confirm if it will actually pass things properly. So if we go into our vectors.s, here we call that, we don't do anything else. Should we do anything else? Yeah, moving x7 into x8. No, I don't know if This is the source register and this is the destination register. Operands. Immediate. Okay, first one is destination. Second operand is source. So it is wrong. This is the destination and this is the source. And x8 is supposed to actually have the syscall number. Okay, then I'm not supposed to use x7. Function arguments register order in ARM. I think it starts from x1. It starts from R0 to R3. So it starts from R0. That's why we are moving it to x7 then, because in my case, which is where the fuck is that? Here I have eight arguments. So if I want the x8 registers value in my 8th arguments, then it should be in x7 register. So it is correct because x7 means 8th arguments and here it is 8th arguments. Maybe one thing to confirm is x means entire 64. Does it hold entire 64 bits? Or is it R0, R1 or something? Okay, so x is the one that is supposed to actually hold the entire 64. So that is also not the issue. Then what we do? Everything seems to be correct. Okay, here we don't care because syscall number is in W8. Is it W8? Syscall number instruction register. It will be in lower half, which is W8. So what the fork am I doing here? I'm taking the lower half, okay, and then I'm moving that into x7. But how do I know if this actually passed? Okay, we can run it. B star is right. Run it. And we are inside the syscall. No, inside the exception handler. Here we check if it is and if it is not equal to that. Now let's confirm what's inside x8. X8 has 0x40, which is actually 64. So it is correct. So now I do SI and I am ANDing something. Maybe this is the operation that is fucking it. After this AND, it's 0. Oh, why the fuck do I even put such ANDs? Okay, we'll remove that. Now we can simply let's move x8 into x7 and see what happens. See, the syscall writer calls. Oh shit. Okay, that's good. Now we have the syscall working. And inside handler, we are inside the syscall. Now let's just call the block write operation here. What do we want to write? We want to write do we call it here or we put a helper and call it there? How do we want to do it? Let's just start by simply calling this is what I want to do. Just call block write with a sector and a data and this. Okay, that is all I'm supposed to do. Nothing much. Maybe I can also say the okay. We go back into our handlers.c and put this and call this after this write done and we put how many bytes we wrote and should we read and what is the caller doing. It will have 3 arguments, I suppose. The first one is the actual file actually, so which does not matter, which is ft, which in our case is always going to be 1, which is standard out, and test is the data that we want to write. So the argument is the second argument, which is register 1 and number of bytes. I think we can only write 5 12 bytes at a time. So let's do this. Let's mark it as 0. And then we can put test I++. I equals 0. Do we have I? No. I equals 0. Equals A. No, let's put W. And let's copy it and paste it. And this is what we want to write. It's going to be 512. Okay. And in our handler, it's going to be second and third arguments. So it is going to be arguments second, which is arg2, and arg3. We do that, and then what can we do? We can print it. We read and print. We'll simply add the read operation here, and we'll see, we'll print it so that we know if it is actually working. Where's the fucking print? I think it's here. Okay, it's here. We'll copy this and get into our handlers. Let's see, and paste it here. And here data is, we need to allocate a data, which is jar data 512, and it's int I. Okay, now let's see. Now we write into that block and read from that block, and we print it, and that is how we do. Okay, we'll set. Okay, we don't have block right. We check and fix. It should be here. Let's just remove this. Remove that. And we call this inside handlers. Let's see. We paste it. Oh my god. What? Okay, it's an address. So I just put it as just. And what about the third pointer? Third pointer should be of size t, uint 64, and it is already uint 64, so it's fine. Now what the fuck? What the fuck do you mean? Wait. Undefined symbol memset. What? What? What the fuck? Do I even have a mem set? Inside user process 1. Inside user process 1. But I didn't even test user process 1 for a long time. How come it's all of a sudden? Something else is going wrong. Okay, let's search for mem set. I don't have any mem sets because I don't remember writing it either. Okay, let's check what are the new things that were added inside our syscall.c and handlers.c. We added this one new function and it goes back to one folder and it includes driver.h. Okay, if I oh shit. I still get mem error. So something else. Then it must be this one line. No, I'm still getting mem error. What the fuck? What did I even do? This is the 3 lines of code I added. kmem.c. Why the fuck are you? Okay, maybe this operation is the one that is fucking with us. Possible. Okay. Maybe it does not want that at all. So for that one operation to work, we need mem sets. Sats. Okay, then we can bring back all our stuff. Now we kill it. And run it. And it did not work. Let's just try with just block right. See if it works. Let's just try with this then. Oh, something else happens. Even now, if now it's not even going into my function. Oh, maybe we remove that. Right? It's possible that I commented it out. No, I didn't comment it out. I have user process and it's assigning and it calls this. We will We'll do what we always do. Put some breakpoints. Disassemble, syswrite, and star syswrite. Okay, we are inside syswrite. We call the service. Oh, okay, we fucked up. We overwrote something. That's why. I think it's alignment issue, because right now this is not there. It got fucked somewhere. And what did we add? We added some extra lines of code and this. Let's do this. Is still undefined. We're jumping into this line of code. Why are we jumping into that? Let's disassemble. What is it? It should be EL1 sync entry, and it is in this location. Maybe did we hard code it anywhere? As our vector table, this is our vector table. And it is pointing to one sync entry. Or is it jumping into some other entry? That's not possible. There's only two entries. Shit show. Oh, I put on it disassemble. Syswrite. Put this and this. And I'm jumping into 8240. And it's an undefined instruction, so I'm not gonna get anywhere. But I'm supposed to be jumping into EL1 sync entry. But what changed? And it was working like a few minutes ago. And I have removed all other stuff that could potentially be wrong. Maybe because I allocated this much space here, that everything else moved down. That's one potential answer. Still inside this. We go here. That's just this right. Inside handlers.c, we did not add anything new. I mean, we removed everything that we added. We have a syscall right, and something is overwriting something else. That's for sure. I'm passing values. It is this right, and I execute this instruction, and I'm jumping into some exception handler, and this exception handler seems to be the one that is reaching, but what is that exception handler is the question. What is this? It's EFFF. Also, it starts with EFFF. Shouldn't it start with 0? Because if we start with 0, it does have something there. What does it have? We can also disassemble EL 0 sync entry. Okay, it starts from somewhere else. EL1 sync entry. EL1 IRQ entry. Everything starts around 3000, and what does it, that 2000 start with 400? It's UART. UART is not working? Wait. It was working for like a few minutes ago. Let's try this time. I'll include this. What the fuck now? What? Implicit right? I mean, it is declared in this right. Oh, I didn't save it. And I stop at this right. And we make the interrupt, and we still jump into some. As soon as we make that request, we are jumping into this undefined previously we usually just jump into some what is it, vector table, because we are supposed to jump here. Something's wrong. Maybe user process does not have the proper exception table register. And what's the table register name? Let's see. So inside here, if we, I guess we set this is break start came in. Okay, don't stop there. This symbol came in. And let's start. Let's stop here. Nope, I have to stop in the virtual task. And then here, now let's type ELR info registers. Vector table register. Oh, fuck you. What? I fucking forgot how we update the table. We somehow update the registers with saying that the table starts here. Something like that. Yeah, it's V bar EL1. Okay, wait, I have a question. From within EL1. Hi. From within EL1. How do we... No, from within EL0. If we start a syscall, which vector table will be used. And the process of Okay, it is going to use V bar EL1. So let's check that. V a register, so we put this. What? Why is it not working? Is the register different? I think this is it. Yeah. V bars. Okay. Retracted. Okay. Okay, for anyone, kernel development. I mean, I've been trying to get some structured syllabus or something like that, because lots of people in the comment section always come up with the same question there. Is there any standard way to start and learn? Maybe there is, because one person did comment giving certain books that they have used, and they were able to use that to understand everything and get into kernel development. But I don't know if that will work for everyone else. From my point of view, I mean, for me it didn't work. I tried some books, it didn't work. So only thing worked for me is that I have some certain understanding of what a kernel is, and probably it is completely wrong with that base, which is already wrong. I just start forming new ideas around it. So let's say I thought RAM works this way, and then I try to search about how it works, and maybe write something around my existing idea of what RAM is, and then form um, new ideas of it that is gonna kill my old ideas and write on top of it. So that's how I'm learning. I don't know if it will work for everyone, because this way I can just take it as small blocks, and I don't have to get the entire picture of the kernel, because it's currently impossible. If someone says that they know the entire kernel, they are probably just lying. Kernel is just too huge, and it's simply not possible to have a full picture of every part of the kernel. So what we can do is that we can convert the kernel into small subsets and understand how that small subset works, and maybe play with it, and then you can build on top of it, or maybe add the other subsets and understand it better. So in my case, I just took the bare minimum, which is writing a simple kernel that will only have a that's simply gonna load into and start executing. I didn't write a, what is it, bootloader, because you have Kemu, and Kemu loads, Kemu starts executing at this Kemu starts executing at 8000. So if you load my kernel ELF into this address, it will start executing instructions from here, and my first instruction is just this, and my first instruction is this. So I didn't write a bootloader. I started off with Kemu, and my current kernel can boot into a small virtual space where I have memory management units and a scheduler and a small block layer now. And currently I'm trying to write the file system layer, and yeah, and then I'll think about what to do next. So in general, the whole idea is just to convert the bigger picture into a small block and write a small implementation of that block, group them together, put it all into a kernel, and then grow from there. Because I have tried even getting directly into the code base of kernel, the actual Linux kernel. I mean, it's good to read the actual kernel, but it's simply not possible to understand the full kernel. That's why even Linux has separate teams for every subsystem. Every subsystem at least has like 10 or 20 people working on it. So yeah, that is how I am taking. Just take it as small subsets, implement it. If you understand it fully, then you can build on it. Maybe it will, even if your small subset is completely wrong, as long as it works, you get an idea of what an actual kernel should be doing. Because from our point of view, there are like small things that has to for sure be in your subset, and if you implement that, that's already good enough. And without that small subset we cannot have that subsystem. So for sure, and you can just ask like what are those things to like an LLM, and it should give you an idea of what is like the basic, very minimal basics of having a small virtual file system or having a small scheduler. Because in my case, my scheduler only does round robin. It simply takes one process, it runs it, it gives a time slice for it, and then let's say the time slice is 30 seconds, that 60 seconds, it will run for 60 seconds, and then it will yield and run the second process that is in the queue. So it just takes the next one that is in the queue and it will run. It's like the basic scheduler, and there's like multiple algorithms that a real kernel can implement, but in my kernel I have only implemented simple round robin. But that gives an idea of what a scheduler is supposed to do and how it should interact with other modules. And I guess that should be enough. Yeah, just try implementing small things. Maybe there is a better book. If I find something, I'll definitely add it somewhere in the comments. But I don't know. Yeah. Okay. I fucking forgot what I'm supposed to do. What am I supposed to do? Yeah, I was thinking about this V-bar because as use. Yeah, thank you, welcome. And as soon as I get into the interrupt handler, I'm reaching this 8,000 to the 8,200 something address, and it's all fucked. No, it's fine. It's all fucked, so we can run it again and see what's happening there. Yeah, we'll break at this right. Now this right is in a different location. Last time it looked. No, I guess maybe it was in the same location. After we run this interrupt function instruction, we are jumping into this 8,200 and something. But what is actually in this V bar? it is supposed to be 8200. Wait. Plus 4000. Then it makes sense. My V bar is at 82,000 and we are jumping into 8 to 400. That means the system is doing what it's supposed to do. It's just that 8400 does not seem to have anything valid there. If we convert it into 100 instructions, that's too much. Let's put 25 instructions. Okay, I understood. This is what happened last time too. I need a charger. We don't have enough space, so we overwrote everything. That's what happens. If we go to our linker, it's here. Here, I think we use few more aligns. Let's see if it works. Nope, it didn't work. Now I have to understand where is it overwriting? My start.s, I'm taking vectors. Okay, we have it hard coded here. See, this is the issue. I just have to make sure that I don't reach till this point, something like that. So if we go here, put this, that, and disassemble this right. And let's also disassemble EL1. So many other projects. I think I guess it's just interesting to understand how it works internally, because also I am working as a security engineer and I have to deal with a lot of kernel 0 days, and in case I'm reading into some kernel 0-day exploit and it says that some scheduler had this bug and it was able to overwrite a certain memory location and we get arbitrary read or write primitive, it will completely glass over my mind and I'll just feel like I have no idea what that is. I just know that if we run that exploit, by the end of it we get something. But it would be nice to understand what actually led to that finding. So someone actually went through the scheduler and they were able to see that the scheduler is not supposed to do that, and they tried to exploit it and they got the actual exploit working. So that's I guess that's my motivation to understanding what what's a real kernel actually works or actually does. Yeah, I guess so. Also, it's really fun, and it's like really like there's too much information probably to understand the full kernel or every subsystem. It might even take more than 10-15 years. Even with all AI and stuff, it's not going to change. The entire kernel is just too big. Understanding it is still going to be a good investment. Maybe you can even find a job that actually optimizes kernel, and you can do something about it, maybe, I guess. I don't know, but my motivation is just to understand how exploits work, because internally almost every kernel exploit is gonna say that the scheduler did this, memory management you did that, or whatever. And if we read that exploit, it will not be straightforward. So yes, so only if we have a small understanding of how those subsystems actually interact, then we can actually read the exploit and understand, yeah, this is how the exploit is trying to meddle with the actual system. Okay, disassemble EL1. What is it? EL1 sync entry. But I'll be in EL0, so yeah. Also, one more thing, I guess still 2022, I really did not understand what is a kernel and what is a user. I know that there's a kernel and there's a user and there's a separation, but I didn't know that. I thought that kernel is running the user process on top of it. So like kernel is always running, and on top of it the user processes are switching. That's how I initially thought, which was completely wrong. It turns out the architecture is the one that is always running, and it has different layers, which is the EL1 and EL0. And kernel, whatever code that runs in EL1 is what we called a kernel code, and whatever code that runs in EL0 is what we call a user code. This simple understanding helped me understand what is a hypervisor, because even at that time previously I was like, if kernel is always running, then if there is something called hypervisor, then hypervisor must also be always running. So there's three code that is always running. So it was like completely hard to picture those stuff. But when I started this and when I understood that the architecture provides the different levels, that is EL2, EL1 and EL0, and whichever code runs in that particular layer gives that different separation. This was like the biggest moment for me. I guess it only happened like 3 to 4 years ago. Until then, I simply did not understand anything about it. I simply thought kernel was always running and user is supposed to run on top of kernel. This is what I thought in like 3 years ago. Rust, I mean, I really liked Rust back in 2021, but yeah, I don't know. Rust is interesting if you just want to understand the security side of programming, because those abstractions will really make you understand what that means. Because if you simply move a variable and reassign it, it's possible to do in language like JavaScript, but Rust does not allow it, because you know that it's already assigned to a memory location, and if you're gonna move it, then you also have to think about who's gonna remove it in the end. If two person has the same reference, and if both of them tries to remove it, then it's double free, and that, like, so it's completely, Rust language is completely trying to mitigate security issues, and it's really good to learn in the beginning, but after, once you get hold of it, and then everything is just unsafe Rust, and you put a wrapper around it. So for that, you can simply write C code, and C is much simpler. But I really liked Rust back in 2021, when at that time everything I believed was completely wrong. So I don't know. I don't know. Syscall. EL1 sync entry. Not syscall. And what the fuck is in 0x8? Which one? You mean the security parts of Rust? Yes. Every feature in Rust is just to mitigate a security vulnerability. They didn't do anything else. Yeah. Yes, I'm from India, but I live in Sweden. Nepal. Nice country. Eight two. Okay, 8200. If I dump 8200, it says syscall write 1. Maybe this is the issue. What the fuck is syscall write 1? I'll just remove this. What happens? Oh, it worked. Oh, it worked. So maybe it happened because we had two different functions for the same thing. Something like that. Where's my k-main? Okay, I'm calling syswrite, and inside syswrite we have this, and if we go into handlers.c, here we call block write. Let's also try the block read. We write to the 100 block, and let's also read from it and see if it's working. Okay, now it's not working. As soon as I remove this, it's not working. Let's just put this and see what happens. Now it's working. No, it did not work. Actually, something is not working within the block layer. Maybe it's the total size. Let's see. Where is it? Here. I just allocate 512 and I pass 512. Now if I try, where is it stuck? Kill it, we run it, and stop, and see chemo again. What the fuck? That's a lot of chemos. Okay, I have to run it. Kill chemo. We come down. We made and status is set to 0. Maybe it worked, maybe it didn't work. No. I'll put full logs. Now if I go back and put 1 and go to end, so we do have exception. We have a page 1 false, and we are from EL1 to EL1. I think 5 means page table 1 error, level 1 error, and for this is the address that we are trying to reach, and this is where we came from, so we will go here. What we can do is we have the syscall number and we start writing to 5000. Now we can just go and which is the print message? I think we just will just search for it. I think it will be in block read.c. Here, block reads, and the final print message we got was index 0 far VA. What the fuck is that? Total allocated. I don't see any such messages here. We have, okay, starting to write. starting to write, prepare, and after starting to write I have a prepared request, but it's not there. What the fuck? Okay, maybe we switched task, because the moment we say starting to write 1000 to size, we have res, which is and then we have something else. Definitely, I feel like we switched. If we actually switched, then we must have switched to the next process. And what's the process? Okay, main. And the next process is just okay, now we can see prepared requests. That's a lot of bullshit. What the fuck am I doing? I'm inside handlers.c and I make a read requests, and read request says that no, I'm making a write request. And then I have a print message. Let's just call to prints and see what happens. You and 64 report, and if we run it, why the fuck there's a read request now? What the fuck am I reading? Maybe it's in the top. Maybe we didn't even reach this. Yes, we did not reach this. We are still somewhere here. This is where we are getting fucked. Why? I have no fucking clue. It was working fine for forever and now it's not working. because we are not even getting into the task yet. Yeah, we init with your driver, which is probably here. Yeah, we init with your driver, and we are getting fucked here. Did we change any fucking thing? We'll remove all other logs. It's just too much for logging everything. And if we now it's actually jumping into the task. So lots of things are going wrong. We have to take one step at a time. Now we were able to move past that, and we were here. Task 1 scheduled, and we jumped into it. Now let's see. This is some means is right. And we have the same fucking error. And what did we try to do to fix this? We removed syscall. We removed this. For some reason we removed it. Where's my vect? That's if we go back to the start. Okay, this is where we left off, because here we can see that we write 2000 into v bar, but v bar execution starts from 2400. Well, we can do that then. But why do I even have to touch this? This was working for millions. Yeah. Okay, I understand the issue, but I still don't understand why it happens though. We can disassemble EL0 sync entry. And if we go into our vector table, EL1 sync entry should have been vectors plus 400. So let's disassemble vectors. Vector starts at 8,000. Okay, so this is the issue. Take this, go to start, we update the table with that. Now if we try and vectors is at 8,000, 2,800, fine. And if we call this, and now we have the proper vector table. And now we are inside the thing, and now we can run everything, and we have it. Oh fuck me, this one instruction just fucked me up. I think it's better to just load it properly so it will be dynamic, because every time I increase the size of the kernel ELF, this hard-coded value is gonna fuck with me. If the ELF size increases, we might have to update this vectors. Okay, then what I have to do is that I simply go to my handlers and call. Let's first start with reads and see if it works, and then we can call read request is complete. So at this point, probably we switched off. Ah, okay, now I understand. I'm not supposed to call block write inside interrupt contexts, because interrupt context needs what is it? Interrupt context actually needs the what is it? Lock, because my block layer I just added because I have this pin lock that I implemented like 2 weeks ago, and I'm going to unmask all the like, so if we are inside the interrupt context, so we are already interrupted, and when I call block write, it's going to turn off all interrupts, so I can never get out of that interrupt, because I'm in a, what is it, deadlock state. Yeah, because I was talking about it, if I can call my block reads inside a kernel context, inside an interrupt context, and I was not supposed to call it, and I did the same thing here, and I guess that is what is happening, at least, because here, as you can see, I have this thing called mask interrupts and mask unmask and interrupts, and if we go into my block layer, here I call that spin lock with mask. So when I call this, I'm turning off all interrupts, because it's a critical section, so nobody else should try to do anything at this point. It should be like atomic operation, everything within this whole thing until this, because I unlock it here, so everything should be inside a critical section, and nobody else should be doing anything here. We can just see what happens if we remove it. I don't know what will happen, because the whole point of adding this is that if two processes tries to write to the same file, they should not overwrite anything. They should properly wait for the lock to come and then do their writes and unlock it. That was the whole point. We can run it and see what happens. Nothing happens. It's the same thing. We have the syscall and we have the syscall called print, and then we get into writes. As soon as we get into write, why am I seeing this? That's my right. I'm here, I'm starting to write, and then do I call anything after that? Okay, I call kmalloc. We don't have enough space. I call kmalloc, and then the rest goes with it. I can do one thing. This should be structs which IO requests are equal to, it should be reserved equal to 0. I can just 0 it. I don't have to assign anything. I can this. Too many arguments for the function call. Okay, something fucked. But whatever, we'll try this first. We'll put this and no. Remove this, put this off, and mark it as rec. No, it's correct. We put rec and then we put struct which q star rec equals to r. Now we take that address and we put it here so that we don't have to change anything here. And why the fuck is it not working? What size? It's here. There it is. No, it's still the same error. So maybe we have other k-mallocs. Okay, we have lots of k-malloc. No, we do have here. Okay, so this is not going to work. If something is wrong with my k-malloc, then I'll have to deal with it, I guess. If not, we're not getting anywhere today. And why is my printf all of a sudden erroring? Type definition. What the fuck did I do? I didn't do anything. Okay, we'll put control. Okay, we unlocked and okay, we did that. What we did is we just simply removed these two parts. And all of a sudden every error message is gone. But the whole point is that this k-malloc is not working. And we are stopping at index. I think here, we go here. And index 0, where is it? Index 0. Okay, we are here. Index 0, virtual address is this. L2 address is also index 0, and we have this. And we go into set table entry. It simply does index is equal to descriptor. And then what is supposed to happen? And then we are supposed to get far allocated done, which we don't get. Probably we need RAM, bro. There is going to be the message. We have what print. How am I supposed to interpret this message now? For every L2 index, we need to create a new table L3. We use the block plus 512 as the logic to find the index. Okay, that's fine. If we try to allocate more than 10 L3 tables, we'll get an error. Or maybe we are trying to link more than 10. Why is there a hard cap of 10? Okay, let's print what's the total. Let's print what we are trying to reach here. And we want VA to PA. That is L to L with total. So we can put VA and PA and what? Now if we try and okay, we only want total one. It's just one fucking index. I wanted this to map to this. Why is that hard? And here index is 0, VA is this, and L2 index is also 0, and L3 table is this. Maybe this L3 table is the issue. Let's see. It should be fine. What is our full range actually? We have D physical. If we go down, we use this logic to create a new L3 table, and in this particular case the L3 table was this, and for some reason it is not possible to have that. Three. Maybe because as soon as I get into this table, which is simply just within the index, table index, which is 0, put the descriptor, we get a table fault. What is the fault we get? I cannot break here because there'll be lots of calls to it, so let me break inside block read, no, inside syswrite, and then I put block read. No, after that I can put set. Is there anything easier to break into? Nope, not this. Yeah, map table entry. This looks better. I guess we can jump into make table descriptor. I did not break there. Maybe the entire kmalloc is not even inside the user process. Maybe that's the issue. Where are we currently? We are inside interrupt context. So we do have the kernel page tables. So it does not matter. Inside the kernel interrupt context, and we try to use map page table entry. Maybe we're not supposed to call kmalloc at all inside this. If we can have a queue for the block read, then whenever the interrupt happens for the syscall, we get into the interrupt handler, we just put a value into that queue and we just go back, so that the actual block read can read from the queue and then execute it. But from within the kernel, I should be able to call it. It should be working. Okay, now let's just write down the issue first of all. Let's write it inside the kernel handler.s. So here, as soon as we call the kmalloc and move L3 table location is getting page faults. And to confirm that, we need to and camera, and remove everything. We'll run it. Okay. Now if we print all interrupts and we have it, we are from EL1 into EL1 and we have a table fault in level 1, I guess. Yeah, 5 means level 1, I guess. Level 0 is 4, level 1 is 5, level 2 is 6. I think so. And the actual address is this 53 something. Why are we trying to write to this address? That's my fucking question. Because last time I checked, we are inside some L3, because here L3 table is this, and for that table we try to use the index 0. Within that table we just write to index 0. And why is that erroring out? Or maybe this errors out. Okay, let's confirm that. Updated table 3. What happened? It worked this time? This time it fucking worked. Because we finished it and we actually read the value. Maybe it's just something is missing, yeah, some extra memory. Now I didn't even find the device. Okay, we'll run it again once more. Let's see what happens this time. This time it worked. So we are here. No, actually. Actually, we did not even reach into the function just by adding one thing. Yeah, because as we know, every time we add this, we also have to calculate the proper vector table index and update that. Maybe it's just better to make that dynamic first of all, which is just to put, okay, let's write that down too, because the overall size is increasing every time I add some code. I have to make the vector table index not address, not hard coded anymore. This is causing trouble. Fix this first, and then we can think about this error. First of all, we need to fix this. We fix this dynamic condition. That is just to, here I'm still hard coding it, right? I just have to make sure I make this work, that is load the vector as a label, so every time it will automatically know the proper address to start from. Currently, if I hard code it like this, and when the size is increasing, I'm overwriting this location with some normal code, and the vector table is quite below this address, and that's what is happening. Okay, we'll fix that. Okay guys, we'll fix this later. I think it's too much for today. I already streamed for 2.5 hours. Okay,